All right, so this is logarithmic differentiation. And do you need to know this stuff? No, but it's kind of like, well, I can put a screw in with a hammer. I don't need a screwdriver, but a screwdriver is much more effective. So this is just another tool in your toolkit. So here's how it works. We have these properties of logarithms that allow us to rewrite logarithms. So it allows us to break up multiplications, divisions, and exponents. So again, this would be product rule, quotient rule, chain rule, and it allows us to rewrite it so that we can avoid them. So before we do that, let's do a little expanding. So we have a natural log here, and what you always want to do is make sure that you have each part with its proper exponent. So there's a video we've already done on this, but we're just going to go over a quick one as a review to know what we're doing here. So we have three parts. We have that one, and then these two are being multiplied. So we're going to have three natural logs for the first one. The second one, let's not put the sign in there because we don't know what it is yet. And then the third one. So the first one is x plus 1 to the half. The second one is x squared. And the last one's e to the x. Now remember, if it's on top, it's positive, and if it's on the bottom, it's minus. And that's our first rule. So if it's multiply, it's plus. If it's divide, it's negative. So these two are on the bottom. They're down here. They would both get negatives. And then if there's an exponent on each one of them, we want to bring that in front. So this becomes 1/2 natural log x plus 1 minus 2 natural log of x minus x ln of e, which is just 1. So if you have an e, it just becomes x. So ln of e is equal to 1. All right, so here's how we use it. What we're going to do is take the natural log of both sides, just like this. And then now we can take the derivative implicitly. So this would become 1 over y, and then it's not an x, so we put y prime. So we're taking the derivative with respect to x. All right? So when we do this, what we're going to do first is expand it. So this would become ln of y equals ln of e to the x. Again, that's going to be this, plus, and then 2, oops, not plus, it's on the bottom, minus 2 ln of x plus 1. It's fine to make mistakes, just go back and check them. So the x comes in front. Remember, the ln of e is 1, and so we can just come back and go bye-bye, just like that. So we end up with ln of y, x, minus 2 ln of x plus 1. So now we have applied our logarithm before we do differentiation. So this is why it's logarithmic differentiation. And we rewrite it. And we take our derivative implicitly. So this is 1 over y, and again, that is not an x, so y prime equals derivative of x is 1. And then now we can apply our nice little logarithm rule. So its top is 2, x plus 1 is bottom, and then that's it. Now we multiply everything by y. So we get y prime equals times y, 1 minus 2 x plus 1. Now the reason I'm putting it as a y is you can now go back and grab your y. So this would become e to the x, oops, over x plus 1 squared, 1 minus 2 over x plus 1. Now we want to kind of bring that fraction together over there, so I'm going to put it off on the side here. 1 minus 2 over x plus 1. So this would be over 1, and then x plus 1, x plus 1. And so we would end up with x plus 1 minus 2, which becomes x minus 1 over x plus 1. Right? So here's the reason that we do this. So this is now e to the x, x plus 1 squared, and then x minus 1 over x plus 1. You see the bottom now becomes a cubed. So we end up with y prime equals e to the x, x minus 1 over x plus 1 cubed. So it's a way to avoid quotient rule. Now if you're like, well, I really just don't like that. Well, let's try it with quotient rule to show you they give us the exact same thing. So we have e to the x, x plus 1 squared. So this would be e to the x, and then this would be 2, x plus 1 to the 1 times 1, right? So this would then become y prime equals, and it's e to the x times that. Now, whenever you apply quotient rule with chain, you got to remember that we're also going to be factoring. This is now x plus 1 to the 4th. So they both have an x plus 1. They both have an e to the x. So y prime equals e to the x and x plus 1. You always take the bottom one. So the e to the x and the x plus 1, that's what we're factoring out. Put a bracket, and then we'd end up with x plus 1 minus, and then I've taken those two out, so I'm now left with just 2, bracket, over x plus 1 to the 4th. So now if we do a little simplifying, that x plus 1 cancels one of those. We end up with, I'm just going to get rid of that equal, y prime equals e to the x, and then x minus 1 over x plus 1 cubed. You can see they're the same. So both methods work. It's just something nice to have in your toolkit. So if you look at something like that and go, geez, I really don't want to do product and quotient together, this is a much nicer thing to take the derivative of. So it's a nice thing to have. You can rewrite it with logarithms, take the derivative. You can see they give you the same thing.